vector product or cross product of two vectors, A vector and B vector are two vectors, and theta is the angle between these two vectors. When you take the vector product, you will get another vector whose magnitude is the product of the magnitude of A and B and sine of the angle between these two vectors. Since you are getting another vector, that vector will have a direction. That direction is given by right hand rule. A cross B. If the fingers of your right hand is in the direction of the rotation, A cross B, thumb will give you the direction of A cross B. Or imagine you are rotating a right-handed screw. The same A cross B, A to B. Now tip of the screw will advance in this direction. So A cross B is also in the same direction. So this is what is A cross B. A vector cross B vector is modulus of A, modulus of B, sine theta, n cap. So n cap is a unit vector in this direction. Now let us see what is B cross A. B vector cross A vector. Now modulus of B, modulus of A, sine. Now minus theta. Here theta is the angle between A and B. The convention is anti-clockwise rotation is taken as positive angle. Now B cross A, that is minus theta, then n cap, but the sine minus theta is minus sine theta. Now modulus of B, modulus of A, they are scalar quantities, so you know it is multiplication is commutative, so this can be written as modulus of A, modulus of B, sine theta n cap. Now minus n cap, this is plus n cap, minus n cap will be in the downward direction. So this is the direction of B vector cross A vector. So this is B vector cross A vector. This is A vector cross B vector. This is B vector cross A vector. So B vector cross A vector is equal to negative of A vector cross B vector, because modulus of A, modulus of B, sine theta n cap, that is A vector cross B vector. So B vector cross A vector is equal to negative of A vector cross B vector. That means vector product or vector product is not commutative. Magnitude of A cross B will be maximum when theta is 90 degree. Sine 90 is 1, then magnitude of A cross B will be equal to the product of magnitude of A and magnitude of B. Then magnitude of A vector cross B vector will be 0 if theta is 0. If the angle between the vectors is 0 or 180, magnitude of A cross B will be 0. Now A cross B is a vector in this direction. This is A vector, this is B vector. Angle between them is theta. So it is in this direction. As per the right hand rule, it is in this direction. B cross A is a vector in this direction. So A cross B is not same as B cross A, but its magnitude will be equal. Direction is different. Now let us see the cross product of unit vectors. I, J, K are the unit vectors along the x-axis, y-axis and z-axis respectively. This is x-axis, y-axis, z-axis. Now I vector cross j vector. It's a unit vector, so its magnitude is 1. J, another unit vector along the y-axis. So magnitude is 1. Then angle between them is 90 degree. So sine 90 is 1. So I cross j is equal to k vector. This is the rotation. I cross j is k vector. Now j cross k is I. Next k cross I, j, in that order. I, j, k. I cross j is k. J cross k is I. Next k cross I, j, in that cyclic order. I cross j, j cross k, k cross I. Suppose you take the product of j cross I, it will be minus k. I cross j is k. J cross I is minus k. If you reverse the order, sign will change. J cross k. Here k cross j minus I. Here k cross I, j. K cross I, j. But I cross k, it will be in the opposite direction. So minus j. If you take I cross I, angle between these vectors will be 0. So sine 0, 0. So similarly, j cross j, k cross k, all these are equal to null vector. Now let's see vector product in component form. A vector is given to be axi plus ayj plus azk, where ax, ay, az are the components along x-axis, y-axis and z-axis. B vector is given to be bxi plus byj plus bzk. Now A vector cross B vector can be written in the form of a determinant I, j, k. Next components ax, ay, az, bx, by, bz. So this is the determinant form. Now A vector cross B vector. Let us see the geometrical meaning. This is A vector. This is B vector. A cross B is a vector in this direction. So it is representing the vector area of this parallelogram. If you take modulus of this vector, this n cap is not needed because n cap is to show the direction. So magnitude of A cross B is magnitude of A, magnitude of B sine theta. That is representing the area of this parallelogram. B cross A is a vector pointing in the downward direction with the same magnitude as A cross B, but it is in the, so it is representing the vector area. The top area is represented by A cross B, bottom area is represented by B cross A. Now a parallelogram can be divided into two triangles. So if you divide this, you will get the area of the triangle. In physics, torque is the cross product of r vector and f vector. Here there is an example. R vector is given to be 2i plus 3j plus 5k. F vector is given to be 3i minus 2j plus 4k. Let us find the cross product and get torque. Torque is r vector cross f vector. I, j, k, then r vector. 2, 3, 5 components. 2, 3, 5. Next f vector. The components 3 minus 2, 4. 3 minus 2, 4. Expand this determinant. I, when you take I, 12 minus 10. So this plus 10. Then j, then plus, the next it should be minus, when you take j, 4 into 2, 8 minus 15 plus next k, then this 2 into minus 2 minus 4, then minus 9, so 12 plus 10, 22i, 8 minus 15 is minus 7, then this minus into minus plus 7j, minus 4 minus 9 minus 13k. See, you are getting a vector. You took two vectors, r vector and f vector. So what you are getting is also another vector. So torque is a vector quantity. Thank you for watching.